So we are going to move on and talk about how to write a physical quantity, how to quote a physical quantity. Remember that when we are writing a physical quantity, we need to give its unit. It's very important because without stating a unit, you cannot tell what quantity are you talking about. And in a similar way, whenever we do any measurement, there is some or the other type of error involved. There's some sort of uncertainty always there. There's some chance of error always present. So in order to write a physical quantity and make the physical quantity sense, we need to give its uncertainty along with the actual value. So if we are calculating length, we need to give the error, the uncertainty in length. Let's say I'm measuring with a scale. I'm measuring a length of 21 centimeter with a scale. So when I'm measuring a length of 21 centimeter, what's the problem? The least count of the scale is 0.1 centimeter. That's the minimum reading I can take. So whenever I'm taking readings, I'm taking measurements using the scale, there's a chance that I read at least 1 mark more or 1 mark lesser than the actual value. So if the actual value is 21, I might read it as 21.1, an uncertainty of 0.1, or I might read it as 20.9, again an uncertainty of 0.1. So I need to give the uncertainty, the chance of error that's present in any quantity along with the actual value. If I'm measuring mass, I'll give the uncertainty in mass. If I'm measuring time, I'll give the uncertainty that's present in the time. So it's length plus delta length. It's mass plus delta mass. It's time plus delta time. So this delta mass, delta length, delta time, what are these? These are the uncertainties in these physical quantities. Delta L is the uncertainty in L. Delta M is the uncertainty in M. Delta T is the uncertainty in T. This delta L, delta M, delta T is also known as the absolute error, absolute uncertainty. So generally whenever we are quoting a physical quantity, let's say X, so we need to give its error delta X. So X, delta X, plus minus delta X. That's how you generally give the uncertainty with a physical quantity. Here one thing important is to note this, that whenever we are measuring uncertainties, we give uncertainties to one significant figure. We write uncertainties to one significant figure. If my uncertainty is coming 1.1, I'll just write 1. My uncertainty is coming 1.12, I'll just write 1. My uncertainty is coming 0.12, I'll just write 0.1. My uncertainty is 0.013, I'll just write 0.01. So I'll give my uncertainties to one significant figure. And moreover, I'll also make sure that when I'm writing the physical quantity that I write, it should be consistent with the uncertainty. It should be consistent with the uncertainty. What does that mean? That means, let's say, if I have a physical quantity 21.13 and the uncertainty, the error in that physical quantity is 0.1. So you see the error is always already given in 0.1. And if you look at this is 21.13. So I'll round it off to 21.1. Why? Because this is to one significant figure, but where is this one significant figure? It's on the 1 decimal place. So I'll round off my value to 1 decimal place. I would not write 21.13 plus minus 0.1. Rather, I would write 21.11 plus minus 0.1. Now this is consistent with the uncertainty. Why? The decimal place where the first significant figure of uncertainty lies, to the same decimal place I've given my final value. If I have measurement as 21.13, but this time my uncertainty is 0.01, again uncertainty is given to one significant figure, but this value is given 21.13. Let's see if this is written right or wrong. See, this is right. Why? Because if you can look at this one, you see that the first significant figure of the uncertainty is on the second decimal place. So that means you need to round off your value to the second decimal place. you need to mention all 21.13 over there. If I take the same example, that's 21.13, but this time my error is one significant figure. You see, this one significant figure is on the unit place. That means I'll round off this value to the unit place too. So I'll write it as 21 rather than stating it as 21.13. सही है? उसके बाद if you look at the next example, again I'm taking the same true value 21.13, but this time my error is 10. Now you can see again this is given to one significant figure, but the first significant figure of error is on the 10th place. This is the unit place, this is the 10th place, so I'll round off my true value to the 10th place. So instead of writing 21.13, I'll write it down as 20. So now we are going to do the first example, the first rule of uncertainties, and that's the addition and subtraction rule. So let's say if you have to add a physical quantity or subtract, whenever physical quantities are added or subtracted, what happens is the absolute uncertainty, it's always added. If I'm adding a physical quantity or I'm subtracting a physical quantity, the absolute uncertainty is always added. Alright, so let's say if you have this equation z equals x plus y, so you are adding these two physical quantities to find the final physical quantity z. You must have taken some measurement to find x, you must have taken some measurement to find y, and definitely when you are doing measuring there is a high chance of some uncertainty. So let's say my value of x that I calculated is 2.3, y is 8.1, and let's say the uncertainty in x is 0.1 and the uncertainty in y is 0.2. So uncertainty in x, uncertainty in y, and my z is always calculated by using x plus y, right? So if I calculate this, z will be 2.3, z will be 2.3 plus 8.1, so that will make it 10.4. So this is what you have done is you have added the two physical quantities x and y together, and you have got your answer as 10.4. That was what was suggested to you by the equation to do. Now since you had uncertainty in x, you had uncertainty of 0.2 in y as well, so there must be an uncertainty in this final value of z, that is 10.4. What would be that uncertainty? You were given the absolute uncertainties, so and you are adding x and y, so whenever you are adding x and y, the absolute uncertainties are always added. So that means if you need to find delta z, it would be its absolute uncertainties being added, and the absolute uncertainty is uncertainty of x, that is delta x, uncertainty of y, that's delta y, and uncertainty of x given to you is 0.1, uncertainty of y is 0.2. All two of them added together will make your final answer delta z as 0.3. Now you always write a plus and minus with your uncertainty, so your absolute uncertainty delta z is 0.3. So you have done two things over here. First, you have found the value of z by just adding the physical quantities. Then you have found the value of delta z, which is the absolute uncertainty in z. 10.4 is the actual value, and what is the possible error in this value? A plus 0.3 or a minus 0.3. So that means you would write your final answer as 10.4 plus minus 0.3. But here you need to remember one more thing, and that is whenever you are giving absolute uncertainty or uncertainty, you always give it to one significant figure. Uncertainties are always written to one significant figures, and when you are writing this answer finally, you would write this answer as 10.4. This is the physical quantity that you have calculated, plus minus 0.3. This is the absolute error in the physical quantity that you were able to find. So it's 10.4 plus minus 0.3. 10.4 is the physical quantity, 0.3 is the uncertainty in the physical quantity, right? So one more thing to remember is that your uncertainty should always be consistent with the your final answer should always be consistent with the uncertainty. What do I mean by that? You find to what significant figure, to what decimal place is the uncertainty given. Like in this case, the uncertainty is 0.3. It's in one significant figure and it is given to one decimal place. I repeat, it's given to one decimal place. So you should write your final answer in such a way that it has a digit which is on one decimal place. That's 0.4 over here, right? So that's how you would write your answer. So uncertainties are always consistent, always given to one significant figure, and like this, right? And your final answer is always consistent with the uncertainty that you have calculated. So 0.3, one significant figure, one decimal place. Your final answer should be also to one decimal place, right? Now another example, the addition and subtraction rule still going on, but this time we're going to be talking about subtraction. But remember that the rule of adding uncertainties is the same. If you are adding two quantities or subtracting two quantities, the uncertainties are always added. No matter if a quantity is subtracted, if a quantity is added to another one, the final uncertainty in the final answer would always come from what? Come from adding the uncertainties, right? So let's say you have an equation y minus x. You are given x as 2.3, y as 8.1, the same as before, and you are given the absolute uncertainty as well, the same. That's 0.1 in x, 0.2 in y. So delta y is the absolute uncertainty in 0.2. Delta x is the absolute uncertainty in x, that's 0.1, right? So when you use these two values, 2.3 and 8.1, to calculate z, you will get an answer 8.1 minus 2.3. Hence you would get your final answer to be 5.8. This 5.8 is the final answer of z, right? But now you know that since you have done the measurement of the calculation of z using y and x, and both y had absolute uncertainty and x had this absolute uncertainty, right? So that means your final answer should also have an absolute uncertainty. Yes, it must have, and that is delta z. That's the absolute uncertainty in z. So I told you that whenever two quantities are adding or subtracting, the absolute uncertainty is always added. So look here, it's delta z is equals to delta x plus delta y. Delta x plus delta y. Delta x plus delta y. So delta z is what? 0.1 plus 0.2. That makes it 0.3. But remember, once again I recall that this uncertainty is always given to one significant figure. Now comes in to write the value of z. So if I need to write z is y minus x, and z I have calculated as 5.8. That would be 5.8 plus minus 0.3. 5.8 plus minus 0.3, right? This 0.3 is the uncertainty. 5.8 is the calculation of z that you have already done. Now I repeat one more thing, that this physical quantity that you are writing, you write this inconsistency with the uncertainty. So this uncertainty is given to one decimal place. My final answer should possess one decimal place, right? So I write it as 5.8. Now this is the uncertainty and the previous one was physical quantity. So physical quantity is always consistent with the uncertainty, right? Now another question on this concept of addition and subtraction. The question says I1 and I2 are two currents coming into a junction in a circuit. The current I is going out of the junction, given by I equals I1 plus I2. So the equation is I equals I1 plus I2. Values of I1 and I2 are determined as 2.0 plus minus 0.1 amperes and 1.5 plus minus 0.2 amperes respectively. You need to find the final value of I and the uncertainty in this value of I. So what you would do is, you know that I1 delta I1, I2 delta I2, right? So your equation is I is equals to I1 plus I2. That means you would add up the two quantities, 2.0 plus 1.5. so your uncertainty is 2.0, sorry, your value of I is 2.0 plus 1.5. Hence your answer is 3.5 amperes. This is your value of I. Right, 3.5 amperes. Now you need to calculate the absolute uncertainty in I, the error in I. So it's delta I equals delta I1 plus delta I2. You are given delta I1, delta I2, and I told you if the quantity is found out by adding two quantities or subtracting two quantities, its uncertainty will be found by doing what? By adding its absolute uncertainties. So the absolute uncertainty is 0.1 and 0.2 amperes. Hence 0.1 plus 0.2, that makes delta I as 0.3 amperes, right? 0.3 amperes. This 0.3 amperes is the absolute uncertainty in what? In I. So that means you will write your final answer this way: 3.5 plus minus 0.3 amperes. There's this next question which says that in an experiment a liquid is heated electrically, causing temperature to change from 20 degrees plus minus 0.2 degrees Celsius to 21.5 plus minus 0.5 degrees Celsius. You need to find the change of temperature with its uncertainty. So you need to find the change. Now you know what, that theta 1, the first temperature is 20.0, theta 2, the second temperature is 21.5. You know that the change, you need to find delta theta, change in temperature. You know that uncertainty in theta 1 is delta theta 1, which is 0.2 degrees. You know that the uncertainty in theta 2 is delta theta 2, which is 0.5 degrees Celsius. So the theta, change in theta can be found, delta theta can be found using theta 2 minus theta 1, right? So that is 21.5 minus 20.0, that is 1.5 degrees Celsius. Now the absolute uncertainties are found by simply adding the absolute uncertainties in theta 1 and theta 2. So it's 0.2 plus 0.5. Absolute uncertainty in theta is 0.7 degrees Celsius. So theta is equals to 1.5 plus minus 0.7 degrees Celsius. Here's another question which says that two set squares and a ruler are used to measure diameter of a cylinder. So you are using two set square and a ruler to find the diameter of a cylinder. So two set squares and a measuring cylinder, and then definitely a ruler to find the diameter, of the measuring cylinder. Now in this case, the cylinder is placed between the set squares like this, and the set squares are aligned with the ruler. So when they are aligned in the ruler, you will find that the reading on the ruler at the opposite ends of the cylinder are 2.95 and 4.15 centimeters. 2.95 and 4.15 centimeters. So you know the readings, the two readings. I'll consider this as length 1 and this as length 2. So that means you can easily find the change in length by using 4.15 minus 2.95 centimeter. So they are asking about the diameter first. Diameter is calculated by L2 minus L1 that I just discussed with you. That's 4.15 centimeter minus 2.95 centimeter. So that's 1.20 centimeter. You have found the length. The next part they are talking about is what is the diameter in the what is the uncertainty in the diameter. So you have calculated diameter as 1.20 centimeter. You need to find what must be the uncertainty. You know that the uncertainty in this scale is what? Plus minus 0.05 centimeter. Plus minus 0.05 centimeter. So I told you, whenever two quantities are added or subtracted, their uncertainties, their absolute uncertainties are always added, right? So L1 and L2 are being added. That means I'll add their absolute uncertainties. So each length, L1, your absolute uncertainty is 0.05. L2, absolute uncertainty is 0.05. So they both added together will give you the final uncertainty as 0.1 centimeter. And you know that the uncertainties are always given to one significant figures. So you have found D, the value of diameter, and delta D, the absolute uncertainty in this value of diameter. So you have uncertainty, which we call the absolute uncertainty. Then you have an uncertainty, which we call the fractional uncertainty. Then we have an uncertainty, which we call the percentage uncertainty. So remember, whenever a physical quantity is found by adding or subtracting two physical quantities, the absolute uncertainty is usually determined in that physical quantity. What do I mean by this? I mean that whenever you are calculating uncertainties by adding, whenever you are calculating a physical quantity while adding two quantities or subtracting two quantities, then you will have to find the absolute uncertainty in that final physical quantity, and that can only be found by adding the quantity, the uncertainties, the absolute uncertainties in each of those quantities, which are used to find the final physical quantity, like we did Z. So whenever two quantities added, subtracted, their final absolute uncertainty is found by just adding the absolute uncertainties in the values.